Hello, and welcome to another episode of Deep Learning Made Easy with the Intel Movidius Neural Compute Stick. I'm Ian Bragg. I'm here with Ashwin Vijayakumar. Ashwin, what are we going to learn today?
Well, Ian, today we're going to learn how to deploy an image classifier onto the Intel Movidius Neural Compute Stick, or NCS for short.
Okay, so before we get into image classification, let's talk about the NCS. Tell me more about it.
Well, the Neural Compute Stick is essentially a developer kit for deep learning. You can use it to design, develop, and prototype smart edge devices like autonomous drones, smart security cameras, industrial machine vision equipment, and many such things. The cool thing about this developer kit is all you need is just this USB key and an existing computer that you might already have, right? It could be a laptop, your desktop, or even an embedded board like a Raspberry Pi or an UP board.
Okay, and given it's at the edge, you don't need the internet, right?
Absolutely not. I mean, take a look at this setup that we have over here. We have a Raspberry Pi connected to the Neural Compute Stick and the monitor, and it's not even connected to the Wi-Fi.
So you'd mentioned image classification earlier. Can you expand on that a little bit?
Well, yeah. Image classification is a computer vision concept where a computer tries to categorize images into specific classes or categories. Now, for example, if I were to take this image over here, and if I show you, Ian, and ask you, what is this?
That's a cat, obviously.
Exactly. So what you did just now is image classification.
Okay, so that makes sense, but given we're talking about the Neural Compute Stick here, I'm assuming that it can do it faster, but can it do it as accurately?
That's a good point. So, until recently, human beings were a lot more accurate at recognizing images. But thanks to the ImageNet Large-Scale Visual Recognition Challenge, the contestants of these competitions have been building deep neural network-based computer vision algorithms, which are not only faster than us, but they're also more accurate than us in recognizing images. So, why don't we put this to test? Okay, I'm going to show you an image on the computer, and you tell me what that image is.
Okay.
Okay? So here's a test image. What is that?
Looks like a RAM to me.
Okay, to me too, it looks like a RAM. So let's go ahead and ask the Neural Compute Stick what it thinks it is. All right, there you go. It not only classified it as a sheep, but it actually tells us what specific species of a sheep it is. It says it's a bighorn sheep.
So I was just wrong initially. I mean, it's smarter than I am.
It's
clearly
more accurate than you are, right? The reason the machine is able to do this is because of subject matter expertise, right? A human's capability of being able to accurately recognize images depends heavily on his or her subject matter expertise, right?
That makes sense.
For example, let's take a botanist, and that botanist can recognize maybe 50 or 60 different species of flowers. But I cannot do that. The ImageNet was trained on about 1,000 categories of images.
Wow.
And there's absolutely no way that one person has the subject matter expertise in so many different classes.
Okay, so going through 1,000 categories like you're talking about, that's got to have a pretty complex algorithm, and I would assume would take a while, right?
Not as long as you'd think, right? Because the Neural Compute Stick is powered by the Intel Movidius technology, which is specifically designed to process neural networks very efficiently, right?
Oh, that makes sense.
Yeah.
Okay.
So why don't we put it to test and see how fast it can process images?
Okay, what do you have in mind?
Well, let's play a game.
A game.
Well, okay.
Okay.
So the game is called Rapid Image Classification, and the rules are pretty simple. Okay. So there's a couple of images on the computer, right? And we're going to go through each image, and we are going to recognize what this image is.
Okay.
Right. And we're going to both take turns doing this, and we'll count how long it takes for us to go through all of those images.
Sounds good.
The person who does it fastest is the winner.
Okay.
Okay.
Great.
All right. Let me bring up the game real quick over here. All right, so just hit the right arrow key to browse to the next image.
So timer starts when I start going?
Yes.
All right, so we have a bird, we have a polar bear, we have an elephant, there's a ram, a bighorn sheep actually, the fox, we have a bunny, that looks like a wolf, a leopard, another elephant, and a cow.
Wow, that was fast.
It's pretty quick.
That was good, Ian. But you know what? You're dealing with an expert over here.
Okay.
I'm going to beat you.
See what you got, Ashwin.
All right. Let's go ahead. Let's give it a shot. Okay, are you ready?
I'm ready. Are you ready?
I am ready. Whoa, that was 10 images in less than half a second.
Whoa, whoa, whoa. You were using neural compute stick, weren't you?
Well, you didn't say I couldn't use it.
That's true, that's true. Well, that's clearly very powerful and very fast, faster than me, unfortunately. So let's say I want to make a project like this to, get my friends and beat them. How can I do that?
Yeah, absolutely. So let's start with the materials needed to build a project like this.
You will need a Raspberry Pi running Raspbian operating system, or a laptop or desktop running Ubuntu operating system. You will also need a neural compute stick. Make sure that your laptop or your Raspberry Pi is connected to the internet, because we will need it to download the SDK and sample code from the Movidius GitHub repository. Power on your computer and use the internet browser to navigate to the Getting Started page. As you can see, step 1 lists the materials needed to install the SDK, while step 2 provides the instructions to install it on your computer. You can either copy and paste the commands or manually type them in a terminal window. If the installation asks you to uninstall OpenCV, please go ahead and say yes. Once the installation is complete, make sure you close the terminal window and open a new one. This ensures that the environment paths have been properly updated. If you would like to test the installation, connect the neural compute stick to one of the USB ports on your computer and run Make Examples in the NC SDK folder. This program might run for a couple of minutes since it is downloading various pre-trained neural networks, converting these neural networks into Movidius graph file, and then running these graph files on the neural compute stick. Now that you have a fully functional SDK, you can download more examples from the Neural Compute App Zoo. Navigate to the previously created workspace folder and type this command to clone the examples GitHub repository. Once the repository is cloned, you can run Image Classifier Demo by navigating to Apps, Image Classifier folder and typing make run. The instructions to run any example in this repository is provided in the corresponding README file. Notice that the application accurately classified this image as a cat. It came back with a certain percentage of predictions. This is the nature of deep neural networks. Rather than giving a yes or no answer, it returns a probability of a few plausible answers. What if you wanted to try a different image or a different neural network? the image classifier app allows you to pass certain command line arguments. You can type -H to list these arguments. Let's suppose you want to run an inference on a different image using a different neural network. You can use the graph and image flag to pass these arguments to the app. Note that each neural network requires a specific input image size, mean, scale, and color formatting. You can set these arguments using the dim, mean, scale, and color mode flags respectively. The labels flag allows you to specify a text file that contains the names of all objects present in the dataset against which the neural network was trained. Let's choose to run an inference using the inception model. The instructions required to run this model is on the README page of the GitHub repository. Notice how the model predicted this image to be an elephant, and it has a confidence level of 99.5%. Also notice that it took about 323 milliseconds to perform this inference. Now let's try to run the same image against a different neural network, say SqueezeNet, and the instructions to run SqueezeNet is also on the same page. The SqueezeNet model also predicted this image to be an elephant, although the confidence level is a little lower than the inception model. But do notice that the SqueezeNet took a lot less time compared to the inception model. If you're interested to run the rapid image classifier demo, which you saw in the video earlier, just replace the image classifier with rapid image classifier from the previous command. Also make sure that the image flag is actually pointing to images folder as against an actual image.
Thanks, Ashton, for coming here and talking to me about image classification using ComputeSync and beating me at the game.
Well, I had fun doing it.
Me too, not gonna lie. And if you want to learn more about Movidius ComputeSync, make sure to check out the links below. Also, keep an eye out for more deep learning made easy using the Intel Movidius Neural ComputeSync. See you next time.